Aside from whey protein powder and caffeine, this is the most researched, most popular, and dare I say most effective sports supplement on the market. Today, we're talking about creatine. What's up, guys? I am so glad to be back with you all. I know it's been a little minute. Today, in combination with my biology class, we're going to be talking about creatine supplementation. And we're not just going to be using bro science, but we're going to be using real science based off research and analysis. For a lot of people, creatine is like the first stepping stone into the realm of supplementation for sports and for fitness. And a lot of people kind of have a bad idea about it because it's kind of viewed, in terms of performance enhancement. A lot of people will take those two and confuse them with a steroid. And this is not the same. I can explain the difference later. But creatine is actually natural. Creatine can be found in food, or it can actually be synthesized by the body in the liver from the amino acids glycine, arginine, and methionine. The average person, in combination with what they get from meat products that they eat, as well as what their liver makes, they get about 2 grams of creatine per day. Now, in a really big nutshell, all creatine does is it helps your muscles work better. Now, a lot of athletes will associate that with increased strength and endurance and power output when they're doing their sports or when they're weight training. But I want to talk about why exactly that is that you see that benefit. Now, the first thing we need to understand is how the body gets its energy for all of the processes that it does. And the answer is ATP, or adenosine triphosphate. Now, this is a nucleotide, and the body gets its energy when it breaks off a phosphate group from ATP, forming ADP. Adenosine diphosphate, meaning it has 2 phosphate groups instead of 3. And basically, when we eat food, we're able to use the chemical potential energy from the food to reattach the phosphate group to ADP, forming ATP, and that's a cycle that goes over and over again, and that's how our body gets its energy. Now, to make ATP, we go through something called cellular respiration. And there's 3 steps to cellular respiration. The first one is glycolysis, followed by the Krebs cycle, and then the electron transport chain. The first step is glycolysis, and I wrote here the products of glycolysis. We start with 2-pyruvate, which will be used in the Krebs cycle, 2-NADH, which will be used in the electron transport chain, and then we get 2-net ATP. We use 2 ATP to get 4 ATP, so it's 2-net, and then we get a byproduct of H2O. And it's important to note that glycolysis does not require oxygen. And so usually when our body goes into oxygen debt, it's because we're doing like an intense exercise. So glycolysis can still continue without oxygen, but the other 2, Krebs cycle and the electron transport chain, cannot. They require oxygen. Now, when we do have oxygen, we're doing the full cellular respiration. We go to the Krebs cycle and we make 2 acetyl-CoA, 4 NADH, 1 FADH2, and 1 GTP. GTP is guanosine triphosphate, and it follows a similar function as ATP, but it's used in just different contexts. And then we're able to take all of those molecules, the NADH, FADH2, and we go to the electron transport chain, and from there we're able to make 28 to 32 additional ATP. So you'll see the majority of the ATP we get comes from that aerobic pathway. Now, what happens when we don't have oxygen is we go into fermentation, because each time we go through glycolysis, we're making ATP, but we have to take the NADH and turn it back into NAD+. So when we go through fermentation, we'll form 2-lactate, as in like lactic acid, and 2-NADH. So that's why, especially when you're doing intense exercises, you feel lactic acid build up in your muscles, because you're in oxygen debt, so you're going through fermentation so you can continue to make energy, even though it's such a small amount of energy. Now, this is where creatine comes into play. When we do have creatine in our body, we use what's called the phosphocreatine shuttle. Now, I put that red bracket there just so you can separate. That is not part of cellular respiration. And the phosphocreatine shuttle can basically reproduce our stores of ATP until we're depleted of it. How that works is inside the mitochondria of the cell, as well as in the muscle cell itself, we have something called creatine kinase. And so when we supplement with creatine and we have, a saturated muscle of creatine, it can go into the mitochondria with ATP, and the ATP donates a phosphate group and uses the associated energy to form phosphocreatine. Now, the way I would explain this is it's like a battery pack for your phone. You still have to charge it up. It's not like magic, but it's going to give you that extra energy for when you're out and working. So if you apply that to an athletic scenario, when you're using up all of your ATP and you're stuck with a lot of ADP in your muscles, which don't serve to give you energy, the phosphocreatine will then donate that phosphate back to the ADP, forming ATP. You, of course, can then use that ATP to continue your exercise, and then the phosphocreatine will go back into regular creatine with a byproduct of creatinine, which is a waste product, will be filtered out by your kidneys and released as urine. So with that understanding, as well as the knowledge that creatine is a naturally found substance found in our food, as well as created by our body, I hope that will alleviate a lot of the negative ideas people have about it. I personally recommend creatine to everybody who is serious about weightlifting, at least specifically. Because it mainly benefits those who go into oxygen debt during their exercise, it's not gonna play as big of a role for people who are doing aerobic exercises and endurance sports that take a long time, but especially for fast twitch athletes like sprinters, or in my case, in a lot of cases who use creatine, is weightlifting. Because it's able to help reproduce the ATP so quickly, it's really, really good for those who have that goal. Additional benefits from supplementing with creatine, although the exact mechanisms for how these benefits occur are not perfectly well known, is there was noticed across a lot of studies an increase in IGF-1, which is insulin-like growth factor, it's a growth hormone, as well as myostatic transcription, which basically means the reproduction and duplication of muscle cells, and lastly is satellite cell proliferation. And a satellite cell is a stem cell specific to muscle fibers. So these are all very good things. Now, the main concern or argument for those who argue against creatine, suggest that you shouldn't take creatine, is pretty similar for all sports supplements of all kinds, is just the side effects. Now, before you freak out that there are side effects, I want you to remember that even like vitamins and minerals, if you go into upper level intake, they have side effects. You can get toxicity symptoms from even these things that we know are very healthy for us and our body needs them to survive. Too much of any good thing is bad, so don't freak out. The main side effect that you'll see from creatine supplementation is water retention. People will call it bloating, but that's really not a good word. Basically, all that means is when your muscles are saturated with creatine, because of osmosis, the muscle cells are going to absorb more water so that there's fluid balance. And that is going to lead to water retention inside of the muscles. Now, that's not going to make you look bloated or anything. In fact, it's going to make you look like your muscles are a little bit bigger than they truly would be without the creatine stores. But across the studies that have been done, that is the only replicable side effect. It's been the water retention. Like I said, that's not actually a bad thing. It can make you look bigger, as well as the additional water inside of your muscle cells can assist with nutrient delivery to the muscle tissue. The issue that a lot of people run into and the negative side effects that you'll see people talk about are similar side effects to what you'll see from just normal dehydration. If you're not properly hydrated and you are supplementing with creatine, it's still going to try and pull in that water into the muscle cell, but it's just going to have to get it from other places in the body if you're not drinking enough water. So it's possible that you could get dehydration symptoms, but the fix to that is very simple. It's just drink more water and you won't see those negative side effects. Those side effects, for example, are muscle cramps, headaches, and heat intolerance, as well as gastrointestinal stress. But like I said, those can all be attributed to dehydration. Gastrointestinal distress is also a very common side effect of an upper level intake of vitamins and minerals. Basically what happens is when you have too much of a compound within your GI tract, then your small intestine lining, rather than absorbing the nutrients into the bloodstream, will let out water into the small intestine, and that can cause diarrhea and other forms of GI distress. But like I said, that's not unique to creatine. You can see that in upper level intakes of vitamins and minerals as well. And if you do have this problem when you supplement with creatine, the best thing that you can do is just eat your creatine with food. That way it'll be slightly slower digesting. It won't be as much shock in the high amounts of compound relative to the nothing else you have in your GI tract. So your body is able to absorb it better, healthier, easier. People also worry about if you supplement with creatine, it could damage your liver and your kidneys. Now, kidney and liver damage are common again to dehydration because those are the organs that filter out toxins from your body. And so if you don't have enough water, then the percent content of the water, the blood that does pass through your liver and your kidneys is going to be higher in toxins than if you were well hydrated. But again, the simple fix to that is making sure you are properly hydrated. In fact, a meta-analysis occurred where they went over 290 non-duplicated studies, and they found that creatine supplementation did not significantly alter serum creatinine levels, creatinine being the byproduct of the phosphocreatine shuttle, and it did not alter plasma urea levels, which is a toxin that is filtered out by the kidneys into urine. You'll notice here as well that they include the p-values. The p-value is basically a number that they calculate when they do studies that tells you what are the odds that these numbers are due to random chance. And so the p-value for the first one is 0.001, and the p-value for the second one is 0.004. The standard of excellence for a p-value is 0.05. So these are very, very good p-values. What that's telling us is there was a 0.1% chance and a 0.4% chance that these measurements that they observed were inaccurate. So those numbers are very, very impressive, and it's pretty clear to see from this study especially that creatine is not going to do harm to the body. Now, again, my opinion on creatine is a positive one. I use creatine. I've used it since I was in high school. I recommend it to anybody, especially if they're trying to make progress in the weight room. But I will say there are limitations when it comes to the study of sports supplements. Creatine I'm less worried about because there are so many studies about it, but especially as you go and branch into less common sports supplements, some limitations occur in the fact that, first of all, a lot of these aren't regulated by the FDA, which doesn't necessarily make them unsafe, but it means that a lot of the people doing the studies on the supplements themselves are the people who are selling the supplements, which means there's oftentimes going to be a little bit of bias, or if they did find results that were negative or scary looking about their supplement, they might not go as far as to publish them so they wouldn't scare people. Another limitation, and this one does apply more so to creatine, is that there aren't as many long-term studies. There are lots of studies that talk about the short-term benefits and short-term side effects, but there really hasn't been much thought looking into how does creatine supplementation affect you over a span of decades and into old age. But all the same, I'd recommend it. I think it's really great and it's completely natural. In terms of dosing, the standard dose is 5 grams per day. You'll hear about people doing a loading phase, and I've never done a loading phase just because, frankly, I don't want to. But basically what that does is it helps your muscles become fully saturated with their maximum holding capacity of creatine faster. And so you don't need to load to see the full effects, but it will help you see the full effects sooner. Now, like I said, normal is 5 grams, but of course it's going to depend on the person, because just as much as someone a lot smaller than me doesn't need to eat as much protein as me, and same for I don't need to eat as much protein as someone who's way bigger than me, it's the same with creatine. So a general guideline to go by if you're interested in taking creatine is if you weigh 120 pounds or less, you can get away with taking 3 grams of creatine and still see all of the same positive benefits from it. The average dose is 5 grams, and so if you're anywhere between about 120 pounds and 220 pounds, 5 grams should be a good number for you. If you are above 220 pounds, or if you're closer to 220 pounds and you want to play it on the safe side, be my guest, you can up it to 8 to 10 grams. There's really not that much harm in overdosing. The only issue is that you might be wasting some of the product because creatine is water soluble. So if you have too much, your body will not store it in the body. It won't lead to toxicity. In that regard, your body will just flush it out through your sweat and through your urine. That being said though, if you do have too much, the odds are higher that you'll experience those dehydration symptoms. So if you supplement with creatine, drink plenty and plenty of water to go with it. So that's all. That's my professional opinion. If you have any questions, please feel free to ask. I would love to help you figure out what is right for you. Take it easy, guys.